Alright, so we're calling this example 3b. We already talked about how the derivative of natural log of u is 1 over u du dx. Or, as Bryce prefers, u prime over u. So let's find, if I said f of x is the natural log of x minus 3, and I asked you to find f prime of x. So now this time, this is u, correct? What is u? X minus 3. And what's du or u prime? 1. So I don't need to worry about it. Okay? But this I will have to worry about the domain with, because it's possible to make x minus 3 a negative number. Alright, so what would I write for the derivative of f of x?
1 over x.
Good, 1 over x minus 3. And the domain? 3 to infinity. Now, the domain of this isn't 3 to infinity, but the domain of the function is now, because we're referring back to the original function. So we're only going to be graphing that portion of the graph. That's what that means. Alright, let's take a look at log. Here's the deal, guys. I would memorize the first two on the first page. I'd memorize this. I wouldn't even bother memorizing this. You hardly ever see it, and you can use change of base to do it. Okay, so I'm going to show you why this works using change of base. Okay, I will derive it for you on a little piece of paper. Okay, according to last year, Properties of Log says we can change the base of any log. So I could change this to a base of e, correct? Which would be natural log. By rewriting this as, couldn't I write this as natural log of u over natural log of a? Remember that? Okay, so I'm going to just use that to show how you get the formula that you get. To find the derivative of this then, we would use our let's see, a constant and the natural log rule. When you take natural log of a, it's going to be a number. So that's a constant, really. So I can rewrite this as 1 over natural log of a times the derivative of natural log of u, and don't we know how to find the natural log of u? Yes. Does that make sense then? So I would just, if I were you, I wouldn't bother memorizing other bases. I would just change it. That's where this rule comes from. 1 over u natural log of a. Do you see I just put them over together, u natural log of a? Is that sinking in? Marinating? Sorry. Alright, let's do it. There are new videos.
Is there really?
Alright.
I cannot wait to see those.
So, no, they're not poop songs. They involve Nico, Brett. That should make you. I don't know. It might be reported to like animal services. It's not torturing the cat, but I would say that Andrew is a little bit rough with the cat. All right. So here's the deal, guys. I'm going to change the base of this. Natural log of the square root of x over natural log of 5. I just changed the base. Okay? Now I'm going to find dy dx. So, by the way, my u is x to the 1/2, isn't it? So what would du be then? 1/2 x to the negative 1/2? Alright, let's do this. So to find dy dx, I'm going to take 1 over natural log of 5, and then I'm going to put u on the bottom, and then I'm going to multiply by du, which we agreed, can't that go on the top then? Can you guys see that okay?
So you really never touch the natural log? You just keep it at the bottom, you really don't touch it?
I'm going to do it without.
Okay.
Yeah. Just gonna leave it natural log of 5. If I wanted to do exact, I'd just leave it exact. Okay, let's rewrite some things. Okay, so first of all, on the top I have 1. Do you guys see that? Yeah, I gotta move it, don't I? Do you see how that 2 is gonna move to the bottom? And natural log of 5 is going to be on the bottom. Okay, we already know that. And this is already square root of x, correct? And doesn't this now move to the bottom? Negative. Okay, so I just to clarify, I moved this 2 to the bottom. The natural log was already there. This is already there. Because it's x to the negative 1/2, I then moved it to the bottom. And that makes it actually kind of nice, because doesn't the bottom simplify? Root x times root x is x. So I have 1 over 2 natural log of 5 times x in whatever order. Or 2x times natural log of 5. Maybe you'd rather do it that way. We're going to leave it. We're going to leave it like that. We should do example 5. This doesn't have anything to do with natural log. This has to do with what I call yucky powers.
Yucky powers. Is that like a real term?
It's a real calculus term.
We'll see that on the
Uh-huh.
exam. Okay, everybody write that down.
Theorem
3.
What was it? Theorem 3 point something?
No, it's
It's Theorem 3.
Theorem 3, Brett, 0 over 0.
Pretty sure that AP board doesn't recognize Theorem 3
Right.
as Theorem 3.
It's just
It would be interesting to see what would happen though, like on
I'll test that for you.
well, you don't get to test that if you don't know what they write on it.
Well, I'm just going, what if I throw one of those? I know.
Okay. We already know the power rule, correct? This is just, we're re-emphasizing the power rule. We're going to do some radicals. So, that's, really? No. I can't believe I did this last year, but I did. Okay. So, if I asked you to do something like the cubed root of 4 power, do we know the cubed root of 4? No. If we do fraction powers, we've already decided that we can write those, or radicals as a fraction power, we can do common denominator. Don't get confused with this. This is the actual power. This is not the same as this. Because we've talked about this too, haven't we? That's x to the 4/3 power, right? That is not what this is saying. This is actually raising x to the cubed root of 4 power. Okay. Why would anyone do that? I don't know. But if we were doing this with like exact values, we could still do the power rule. It's just that we would rewrite this as a difference of things. So, according to the power rule, that 5's in front, doesn't this come down? Okay, so we would have the cubed root of 4, whatever that is, times 5, because that's already there, times x to the, and we would have to decrease the power by 1, right? Oh, my fault. It is. Do you guys see how it's a, I think I stopped myself in time. This is a whole group of things. This is actually chain rule, so I'm going to I'm going to just do that. Remember, I just leave the 5x in the parentheses. Alright, and then I have the power of the cubed root of 4 minus 1. Do I know what that is? No. I mean, let's at least approximate what it is. We're not going to write it down, but just so you know it is a number. The cubed root of 4 is like 1.587. Okay, so it's like about 0.587 power. Just FYI, it is actually a number. Okay. Hold on. Wait, I'm not done though. This is chain rule because remember I brought the whole thing down to the front. There's the front. And now I have to multiply by what's inside, which is a 5. Alright. So I would have 5 times the cubed root of 4 times 5x to the cubed root of 4 minus 1 power. Yowzers.
Yummy.
Yucky powers. Okay. Last thing I'm going to talk about. So one of the harder parts of 3.9 is a concept called logarithmic differentiation. And the reason it's hard is it's kind of hard to identify when you need to use it. Okay? So I want you to just read through this little statement, please, to yourself a minute.
I'm going to prove that too.
Silent reading. Read the statement, please. Okay. It says sometimes the properties of logarithms can be used to simplify the differentiation process, meaning that before I start, logs are not maybe our favorite thing, right?
No.
But before I start the process of differentiation, logs do have some important qualities, namely, don't they bring powers down?
Yeah.
So, do you see right now that this has no natural log involved at all whatsoever? But if I would start to try to do this, I would have to bring the cosine x down to the front and then reduce it by 1, and that's not going to really help me a whole lot. So, especially when you have another function in the power, we use something called logarithmic differentiation. And that's just a fancy word for we're going to first take the log of both sides to bring the power down, then we're going to differentiate. Okay? So I am not changing anything right now. I am going to use my property of equations, which says if I do something to one side, I can do it to another, correct? I am going to not take the derivative yet. I'm going to take the natural log of both sides. If I would do that, I would have natural log of y, correct? And over here, if I took the natural log of this side, what would happen? Cosine x would come to the front times natural log of x. Okay. Now I'm going to use implicit differentiation. Which just means I'm going to differentiate both sides. If I see a y and I'm differentiating with a y, what am I going to need to add in? It is not going to be so long. Relax. Stop being a baby, Brett. All right. What's the division, or what's the derivative of natural log of y going to be? 1 over y dy dx. Focus. All right. Over here, we're doing the derivative of both sides right now. This is what I'm doing. Taking the derivative of both sides. Over on this side, isn't this going to involve product rule? Cool. This is fun. First d second, we're going to write cosine of x. What's the derivative of natural log?
1 over x.
Times 1 over x plus natural log of x times negative sine of x.
Good job, guys.
This isn't that bad. Okay, now I just have to solve for dy dx.